Imagine you take apart a piece of equipment. When you put the equipment back together, somehow you have an extra screw or two. You find that a screw is missing. In either case, you know something went wrong. You should end up with the same amount of material that you started with, not with more or less than what you had originally. This is similar to the idea of conservation of mass that we're going to learn today. If you build a campfire, you start with a big pile of logs. As the fire burns, the pile of logs slowly shrinks. In the end, all that's left is a small pile of ashes. What happened to the matter that you started with? It may seem that it was destroyed by the fire, but in fact, the same amount of matter still exists. Suppose you had measured the mass of the wood before it burned, and the mass of the ashes after it burned. Also, suppose you had been able to measure the oxygen used and the gases produced by the fire. You can see that the ashes and gases combined would have the same mass as the wood and oxygen you started with. This is also the main concept of the law of conservation of mass, which was established by a French chemist named Antoine Lavoisier in 1789. The law states that in a chemical reaction, no matter is lost or gained. In other words, the total mass of the reactants equals the total mass of the products. It is for this reason we always balance chemical equations. For example, the burning of magnesium. Oh, this needs balancing. All the atoms must be the same on both sides of the chemical equation. It's easy to see if we draw out the atoms. Rearranging themselves to form the products, you can clearly see that no atoms have been gained or lost during the reaction, so the mass is conserved. Let's say if a reaction starts with 6 grams of magnesium and 4 grams of oxygen. We must have 10 grams of magnesium oxide as the product. Here is another example in which methane reacts with oxygen. But is this reaction balanced? Let's count the carbon, hydrogen, and oxygen atoms on each side. It's easy to count if we draw out the molecules. Carbon, 1 each side. Oxygen, 2 to start with, but now 3. Hydrogen, 4 to start with, but now only 2. To balance the hydrogen, we need to add 2 more hydrogens on the right. To do this, we add another water molecule. Now, let's see, is this equation balanced now? The carbon and the hydrogen balance, but we have 4 oxygens in the product, but only 2 in the reactants. So, we add another oxygen molecule to the reactants. Now, we have conserved mass. So, keep in mind that every time you balance chemical equations, the total mass of the reactants must be always equal to the total mass of the products.